Everyone, and Rupen, thank you for seeing you. Rupen, you have also joined. Professor Bharti has also joined, sir. Uh, all your students and all who have deep respect, affection for you, uh, all of them have joined today to hear you out. So, dear friends, my name is Shailesh Agrawal. I am Executive Director of Building Materials and Technology Promotion Council, and I think I'm honored and I have deep pride in um, today we have Professor CVR Murty. Before I formally introduce him to all of you, अच्छा जसवंत, welcome जसवंत. तो देखिए आपके सारे स्टूडेंट यहाँ पर हैं आज. So before I introduce Professor Murthy, let me just tell you about the initiative being taken by Ministry of Housing and Urban Affairs. You know, in order to promote new construction systems, disaster, practices for disaster mitigation and management, and also climate uh, uh, change mitigation strategies. Government of India under Pradhan Mantri Awas Yojana is running a technology submission through which state governments and other stakeholders uh, are being, handheld and also being imparted education with regard to thermal comfort, disaster mitigation management, safety, resilience, whole lot of things. So we, being technical partner to the ministry, we started this initiative of webinars wherein every third Wednesday of every month, we conduct a webinar on a relevant topic to be given by, best of the experts from industry, from academia, and from other, organizations. So today, before this, we had 4 webinars, and all the webinars received very good participation. More than 200, participants were on board, and all these webinars were appreciated and received very well by the participants. So taking this forward, today we have with us Professor CVR Murthy, and before I formally introduce him, I can tell about myself. I was pushed into earthquake engineering by none other than by Professor Murthy. So whatever little earthquake engineering I know, it's because of Professor Murthy and Professor Iyengar. They literally pushed me. Without, before that, I didn't know even about horizontal acceleration and all those things. I was pretty good doing distress buildings and other things. So thank you very much, sir, for introducing me to earthquake engineering. And I, if I have to say, I'm yet to find a teacher like you, because such an affectionate teacher, and we all who are gathered here as your students are big fan of your presentations, your way of talking and the way you speak, and believe me, I sometimes try to emulate you. So with these few words, let me formally introduce Professor Murthy. Professor Murthy is a PS Rao Chair Professor of Indian Institute of Technology, Madras. Before that, he was Director of the IIT Jodhpur, and before that, he was Triple IIT Hyderabad Director. He is also holding a prestigious CED 39 as its chairman. CED 39 is Earthquake Engineering Section Committee of BIS, and the entire Indian standards on earthquakes are being revised, and very comprehensive codes are going to be put into practice, and that work is being done under the chairmanship of Professor Murthy. It's a mammoth exercise, and he has been doing it with the help of other technical members. His specialization, although he has written only structural earthquake engineering, but I mean, name anything in civil engineering, and he can give lecture on that subject. His research interest is in the area of nonlinear behavior of steel and reinforced concrete buildings and reinforced concrete bridges. Professor Murthy has undertaken post-earthquake surveys to document valuable lessons after all the significant Indian earthquakes. He was team leader of a unique EERI reconstruction reconnaissance survey undertaken after the massive reconstruction operation after the 2001 Bhuj earthquake. He has contributed to significant revisions of the Indian seismic codes for buildings and bridges. He has conducted very successful continuing education program on seismic design in India, Nepal, and Bhutan. Professor Murty is the author of very popular IIT Kanpur and BMTPC Earthquake Tips, a public education series on learning earthquake-resistant design and construction, published regularly in leading national newspapers and journals. The Earthquake Tips uh, have received the Best Construction Technique Award from the Indian Concrete Institute in 2005. And sir, believe me, even today I receive a lot of phone calls to get these earthquake tips, and most of the the persons from academic, they go through earthquake tips before appearing into their promotion interviews and all. Really, I mean it. Professor Murthy is so nicely written, so lucid, the explanation given in those earthquake tips, easy to understand and comprehend. Professor Murthy is also principal author of National Disaster Management Policy and Guidelines with regard to earthquakes for NDMA, which is a policy document of NDMA, Government of India. This is the primary policy document identifying comprehensive action plan items to be undertaken towards seismic safety in India. So with these few words, I invite Professor Murthy to deliver his lecture, and I urge and request all the participants to mute their mic in case you have questions. If Professor Murthy permit, then we will take that after the end of his lecture. In the meantime, you can write your questions, whatever comes to your mind, in the chat box, and then we will take it up depending upon the time availability. So with this, over to you. Rupen, would you like to say something about Professor Murthy before we ask Professor Murthy to start his lecture?
No, as you, very good afternoon, everyone. Thank you for this opportunity. I think what you summarized it very nicely. And some time back, I was just looking back, and then I think some of us have been knowing him for more than 2.5 decades. So there's a lot to speak on, but I think I will not come in the way. Let us hear from him first.
Okay. So, sir, over to you, sir. Thank you.
Thank you, Shailesh, and thank you, Rupen. Good afternoon, ladies and gentlemen. When friends introduce you, there is a danger that they tend to add emotions and facts, and that is where you get overwhelmed. Before even starting this lecture, I am touched by the affection I received in the last 3.5 decades in the country after joining academia, but also from all the individuals who I have interacted with and whose pain I could see in terms of earthquake safety in India. And that is why we have chosen the subject of implementing earthquake safety in India. What more that we need to do today? I'll talk in 3 parts today. Earthquake resilience, the distractions that we have, and 2 critical actions that we can take right away. Before we begin, I want to just put a few items on the table for you to ponder on the subject of earthquake safety. Anything that we want to build has to follow 5 tenets, and these are safety, functionality, sustainability, aesthetics, and economy. The top 3 are in the fixed order: safety first, functionality next, and sustainability third. And then the last 2 depend on how deep our pocket is. If we can put more money, aesthetics goes up. If you put less money, then economy goes up. But bottom line is, the last 4 will survive only if the first one survives. And hence, the safety has to be brought into the driving seat of the built environment. That is the main appeal in today's lecture. When it comes to safety, civil engineering structures are blessed with the fact that each day we have to face all the 5 elements of nature. And today I'm not going to spend attention on all of the 5, but only one of them, which is related to the earth. So going back to time, 140 years, many lessons were learned from the earthquakes that happened worldwide over the last 140 years. But what is more difficult is that many were not learned also. The first significant earthquake in India the 1897 Great Assam earthquake made the scientists worldwide and engineers worldwide understand what is earthquake, what is an earthquake. And it showed that the ground itself can go up and down by about 500 meters. It showed that stone boulders can be thrown up in the air, meaning the acceleration value is more than 1g. It showed that the ground will move by large amounts, 10 to 15 meters laterally. It showed that anything that is brittle, stone over stone, brick over brick, without any reinforcement, can come down in no time and cause a threat to life and property. So the 1897 Assam earthquake taught us that earthquakes affect people, nature, and structures significantly. Another important earthquake in the world, the 1923 Great Kanto earthquake in Japan, showed that earthquakes have cascading effects, especially fire following the earthquake. The 1960 Chile earthquake showed such an extensive loss of life that it became obvious to the world that collapse is not acceptable in structures when it comes to resisting earthquakes. The 1971 San Fernando earthquake told us that the earthquake resistant design of bridges is different from that of buildings. The 1994 Northridge earthquake told us that damage to non-structural elements can be very expensive and even jeopardize the functionality of the building and hence not acceptable. The 2011 Christchurch earthquake changed the entire line of thinking of the past century and said for the first time that damage is not acceptable. In all the previous earthquakes, we were hearing that collapse is not acceptable. But now, for the first time, an entire city said loudly that damage is not acceptable. The 2017 Mexico earthquake told us that there are a large number of structural systems that we are continuing to adopt, but they perform so poorly that it is not acceptable to continue them anymore. And the classic example of this earthquake was 67% of the buildings that collapsed have flat slab systems, structural systems adopted in them. So in the 1960s, when no collapse was agreed, the philosophy, earthquake resistant design philosophy, led to basic objectives. And it said that structures may go through damage under extreme shaking, but should not collapse. But after the 2011 earthquake, New Zealand earthquake, the new set of objectives were brought in which the focus was that there should be very, very limited structural damage. There should be almost nil downtime. There can be a possibility of a very limited need for retrofit under extreme shaking. So the objectives in about 5 decades changed, in about 6 decades changed, and we need to recognize why they have changed. One of the bottom lines was that there are countries that fought hard to eliminate loss of life. And those countries are the ones that are now saying that we want to reduce damage. For a nation like India, we still are on the first item, which is the value of life. What we need is to recognize from the basic objectives itself that no collapse should be assured first in India. And once we have gathered together and improved our systems and processes, standards and education and risk reduction successfully in terms of loss of life, then our next objective will be that we want to say that we don't want to have damage. Today, without recognizing the actions and implementing the actions for the basic objectives of earthquake safety, we can't afford the luxury of getting into the second level because the subject is a little nuanced in terms of what extra needs to be done ensuring that the damage is reduced. I will dwell on that today, but the focus for us is that can we set value for life and give priority to no collapse and achieve that in this country to begin with. So let me start by saying, let us build earthquake resilience. The dilemma that we are going through is that on one side, we are allowing damage and we want to say, but we don't want any casualty. On the other side, we are saying that we don't want any downtime. Our bridges should work, our structure should continue to serve, and the cost has to be low. All of these can be a little bit overwhelming for a designer to take care of at the time of design. But when standards are developed, some of this can be embedded indirectly in the process. So the essence is that if you keep allowing damage, you are risking life. And if you reduce damage, you are building resilience. In summary, if you want to have a resilient construction, you should minimize the damage as much as possible, which means that you will have to spend a little more in terms of safety. Talking about cost, the initial cost will be a little higher in the case of the resilient structures, and the initial cost will be lesser in the case of risk-based structures. But I would think at this point of time, instead of going directly to resilience, we need to come middle path, take a middle path, and talk about structures which will have less damage and which will have less retrofit costs. So the cost that we are seeing on the vertical axis here on the right-hand side is actually the life cycle cost, not the initial cost alone, but the life cycle cost will be much lesser. Now, how do we really achieve this? That is what we are looking at today. And one of the important understandings that we must take forward is what exactly is earthquake disaster management or earthquake risk reduction. If you understand that, you will understand why or what exactly we need to do in India to go forward. So disaster management has two parts. One is before the earthquake and second is after the earthquake. Before the earthquake, there are three major actions, which are prevention, mitigation, and preparedness. And after the earthquake are response, rehabilitation, and reconstruction. Now, when you look at disaster management in greater detail, if you look at the various sub-items in that, you will notice that there is a share of industry, government, and academia in the work to be done towards earthquake disaster management. And the big ticket items for us to become competent are safe constructions and having disaster management plans, undertaking search and rescue, livelihood restoration after the earthquake, and built environment restoration so that people can continue their lives without any undue delay. Now, if we go further into finer details one by one on earthquake disaster prevention, these are the 6 elements that we're talking about. Prevention can be further subdivided into 15 more activities. And again, there is an equal share for the triad of academia, industry, and government. And we are looking at instrumenting the nation with strong motion instruments like displacement meters and accelerometers so that we will be able to capture the earthquakes that are happening and improve our earthquake hazard assessment. At the same time, we need to explore whether we can do early warning or earthquake alerts in the near proximity of the earthquake affected areas. Forecasting has always been a challenge, and the last best forecast that we could hear of in the documents is the 1976 earthquake. But then prediction, forecasting, these words are often crowded by many other interpretations. Because the bigger question that comes is evacuation. And this is typically the reason why in earthquakes, disaster prevention is not a very exciting item, right? We'll go forward and look at disaster mitigation. I think the big ticket items that we need to undertake in the country are sitting in this set of 15 items. Once again, all the three partners will have work to do, but the key items that we require are to know what is the built environment, what are the typologies of structures we build, buildings, bridges, water tanks, silos, bunkers, chimneys, and so on. We need to begin technical education formally in our colleges of technology. We need to have adequate number of full-scale testing facilities in the country. We need to build robust safety standards, and above all, unless it is legally required through a Structural Safety Act, we would have an issue in terms of trying to implement mitigation, right? Disaster preparedness goes alongside mitigation. The mitigation is about the built environment and the preparedness is about the people. And hence, we need to do a lot more work in trying to sensitize the people on the activities that need to be undertaken. And in this, we are talking about first item is communicating risk to the people. Second is mass media communication on what exactly needs to be done about earthquakes. At the systemic level, emergency operations centers have to function and function actively throughout, even in peacetime. Mock drills need to be conducted to show people how large human dynamics will come into play when an event of an earthquake happens. We also need to recognize that the state disaster management authorities and the district disaster management authorities have a lot of coordination to do, and that is where the preparedness game reaches the excitement that there is a chain of command and we follow that throughout the state. Response is a compulsion for us, and when we look at response in the country, we're looking at a partnership. This time around, we won't draw the vertical lines. It's not a silo kind of a situation. It's a partnership situation after the earthquake. We are looking at governments, community, and people to work together. And the big ticket items there are the emergency operations center should watch the movement of men, material, matter, identify needs, and push the search and rescue teams accordingly, activate the temporary shelters and the civil supply groups. And for the medical support, the triage has to be undertaken. And above all this has to happen very quickly in the golden hour response. The fifth item is actually disaster rehabilitation. That is, earthquake has happened, you have been moved to temporary shelters, but then we need to be taken care of both mentally as well as in terms of coming back to livelihoods at the earliest opportunity. And hence, we are looking at critical items like ex gratia, physical health standards, medical health support, economic activities to be restarted, and social activities to be begun so that the trauma of the big event does not linger too long in the hearts of the people. The reconstruction, which is the last item, when a major earthquake happens, a large amount of the built environment is expected to be brought down, and hence we need to reconstruct that. And that is why we need focused attention on earthquake disaster reconstruction. Again, we need to know what are the safe designs of houses and structures, and traditional construction will give you a lot of knowledge on that. How much is the compensation available for constructing those houses? Should the houses be built by the owners or contractor driven? And should it be at the same location where the previous one fell down or at new locations? And above all, we're looking at completion of permanent shelters so that people will continue their lives back again as before the earthquake. What you noticed just now is about 100 items that India needs to do in earthquake disaster management. You also saw that prevention will be an issue for us, and the main focus for us should be mitigation and preparedness. And we have a compulsion of doing response. But it would be best if we do not spend our youth on prevention of earthquakes, because preventing earthquakes is not possible. What is possible is preparing to face the earthquakes. The structures will face them if we are having good mitigation. The people will face them if you are having good preparedness. And whatever losses will happen because of the construction that already exists, we will go on through response. And that is something that will be with us for some more time until we replace our unsafe structures with safe ones or earthquake resistant ones. So items 4, 5, and 6 will be with us, but we want to minimize 4, 5, and 6. The way to minimize 4, 5, and 6 is to increase 2. Once you increase 2, only then we will reduce 4, 5, 6. So once again, drawing your attention on 5 aspects of earthquake disaster management cycle that all of us need to know about and learn and build in the road ahead. Now, if we have to implement all of this, one more item we need to understand is one, the earthquake trio that we call. First is the hazard, second is vulnerability, and third is exposure. Hazard is about nature, vulnerability is about the built environment, and exposure is about how many people, how much of the nature or how much of the built environment is getting affected when this hazard is realized. All these three come together and tell us what is the risk involved. When we look at hazard and vulnerability together, it tells you about the structural risk. Is the structure capable of resisting the earthquake or not? But when you bring exposure also into picture, then we call this as community risk. The community risk is something that people will be able to relate to, and structure risk is something that the technical people will be able to, technical professionals will be able to relate to. So our intention is to recognize that while hazard can only be estimated and nothing is exact about it, we need to keep improving our hazard estimate. And this is where earth scientists and engineers will come into picture. But what is controllable before the earthquake is the built structures, and that is where architects and engineers come into picture. But on the third item of exposure, direct responsibility of this will be with the municipality to not load too many people on structures that are liable to collapse during an earthquake. Okay, so what it seems is that if you reduce structure risk, you're reducing community risk. And that tells us that all eggs are in one basket, and that basket is sitting on vulnerability. If you can make safe structures, you will eliminate a large amount of the pain and agony that we are going through in earthquakes. So in this golden triangle, we have hazard, exposure, and vulnerability. The first priority is to fix vulnerability. Second priority is to reduce exposure. So vulnerability, we want to reduce as much as possible. Exposure, we want to keep it at the optimal level, not too high, so that we are able to increase the use of the built environment also. So some structures like services, governance, and people habitat will definitely want to make sure that they are on low vulnerability. You can't afford them to be lost, because post-earthquake, they're required to stand there and provide the function that they're supposed to serve. But exposure has 3 items in this. Out of all the 3, nature and people will be the items that we want to focus on. And the built environment is the element through which we will be able to guarantee nature and natural environment and people. So vulnerability, our effort will be to reduce the vulnerability. Our effort will be to reduce the exposure. Now, hazard is not in our hand. It can be any of these. Some places will have low hazard, some places will have high hazard. But if we can continue to work on the right-hand side of the triangle, which is the vulnerability and the exposure side, the hazard will not become a worry for us. So we need to reduce risk. That is what we need to do. And the way to reduce risk is what we are looking at. There's an earthquake and suddenly it incapacitates us. The way to reduce risk is to see if we can build structures such that they will have less and less downtime. Now, the structures that are large in number are the normal structures, which are the habitat structures. Next are the important, next are the critical structures. All these structures will need to have a graded way of design so that we are able to ensure that the loss of life is not there, but after a little bit of an effort in terms of post-earthquake retrofit actions, we can reuse those facilities. And very clearly, when it comes to the structures behaving in that way, there are design strategies over the years that we have learned. One is the stiffness based design, which never gave us any resilience. That means we were never able to come back to the normalcy above the zero line before the earthquake. And it is only the strength based design with capacity design that brought a little dignity into it. But even that is found insufficient in structures like the bridges. And hence, displacement based design will come into picture in the road ahead to protect those assets. But eventually, we are believing that the structures will go into a much more comprehensive way of designing, which is energy-based design. So the roadmap of going from stiffness-based design to energy-based design is what the Bureau of Indian Standards is working on and trying to improve the provisions each year passing. As Dr. Shailesh Agarwal just mentioned, this revision of the Indian standards is a comprehensive one, but after that, we're believing that we will do incremental changes only, so that engineers need to know only 2 or 3 new things every time we revise in a couple of years. So the truth is that we have no money and no time to keep retrofitting structures or to keep losing lives. And so we need to get it right the first time itself. And that is where we need to reorganize ourselves, all our energies. Now, one of the things that is needed for this is the people who can do it. I'll take only the subject of construction. When you need to do any work, you need people of all experiences and competencies which are acceptable at the field level. Like, as you go up on the triangle, your experience increases, your wisdom increases, but you must enter this triangle only if you are a competent person. Now, to conduct 100 crore civil engineering construction activities, we will need about 50 engineers per year to complete that task, right? Now, if India is going to spend about 20 lakh crores in 5 years, which means 4 lakh crores in a year, we need about 2 lakh engineers to do the construction at site, right? Let's see how much do we have on the supply side. Every year we graduate about 15,000 civil engineers. This is today's number. Yesteryear number is a little smaller. So in the last 30 years, let us assume that an average of 5,000 are there who are joining, working, and staying in civil engineering over the last 30 years, which means we have about 1.5 lakh civil engineers who are competent and who will serve the needs of the nation. This tells us that we are about 50,000 engineers short, civil engineers short as of today. Okay. So with that as the backdrop of where we stand on earthquake disasters and disaster mitigation, let us now look at the 2 distractions that we have in our eyes. First distraction is everybody wants a wow kind of a structure. And everybody is excited about something new. Everybody wants everything new every day. With that kind of infinity, we are facing this nation with a problem of earthquake safety. It seems that every structure cannot give us wow feeling, because wow also costs a lot of money, and wow also has its own liabilities. So wow needs to be controlled in all our structures, and the wow should be once in a while. You know, the signature structure should be very few, and most of the structures should be stronger on safety, functionality, and sustainability. Okay, when you look at this structure, which was built and occupied and it is functioning, this is also wow, but this is a simple structure and it is doable structure. It doesn't have extravagant activities, but has a little bit of an architectural touch and finishes and has done very well. So what we learn from this is that we need to choose beautiful but regular architectural forms, not irregular architectural forms. That is where I think the difference will be, that we need to be modest in our constructions, in our expectations. And if you can think of yourself that every day you are having a festival in the country, after a week you'll get tired of festivals. And so festival should come once in a while and give us that energy to come together and regroup ourselves and redefine our direction. What we mean to say is that today, form and safety are performing independently, and hence we don't have resilience in our structures. And if we want form and resilience to happen in our structures, form and safety have to work together in one unit. And that is when we will see that loss of life and loss of property can be reduced significantly. I'll come back to the issue of cost of structural safety and put value for money. We are looking at whether we have accepted safety or not accepted safety, right? If you accept safety, then the cost has to be higher. If you don't accept safety, then you will make cheap structures which will not be able to resist the effects of earthquake shaking. As straightforward as that. So we need to decide whether we want to make cheap structures or safe structures. And I'll talk about the cost also. The cost is not prohibitively high. This is a number from one of the Class A cities in India, and it tells you that in the construction of a hospital, the structure costs only 10,000 rupees per square meter, while the total hospital costs 10,000, a lakh of rupees, right? Which means that only 10% of the cost is of the structure. And even if that has to increase by 20% on the structure cost for earthquake safety reasons, then the total project cost is only increased by about 2% on the whole. And you come to commercial, the structure cost is 10,000 out of 72,000. And you come to residential, 15,000 out of 70,000. And residential MIG, 10,000 out of 5,000, 50,000, which means that about 2 to 4% increase in cost is going to be there when you talk about earthquake safety. But the gains are that you will be alive. The gains are that none of your property, refrigerator, TV, study table, computers, gas cylinders, all of this, you don't have to buy again after every earthquake. And that is the advantage of providing this little 2 to 4% additional money at the beginning. But the magic is to find the engineer, to find the architect who can do this for you without hesitation and without selling you the reverse, that cheap structures are the best structures, right? So who are responsible for the structural safety in India? The architects, the builders, the contractors, the designers, the engineers, the faculty members, the geotechnical engineers, the homeowners, the individuals, the judiciary, the knowledgeables, the lawyers, the men, the owners, the professional societies, the quacks, the researchers, the structural engineers, the teachers, the users, the visionaries, the women, the xenophiles, the youth, and the zealous. Xenophiles, I want to say once more, because I've been hearing this a lot more. Xenophiles are those who always believe in the other countries. And I keep hearing that that country is doing this, that country is doing this from many persons. But I would say what is good for them is not necessarily good for us. And hence, we need to focus on what is good for India and build that today for ourselves. In the third segment, I want to talk about two critical actions. Now, we talked about 90 to 100 activities that we need to do to make India safe. But it would be improper for me to tell you to do all those 100, right? But I can summarize all those 100 into 5 bins here: earthquake safety policy, capacity development, earthquake retrofitting, techno-legal regime, and risk communication. In this 5, again, I want to pick only 2 of them for implementation immediately. With the available competence in the country, we can do this. And those 2 are number 3, earthquake retrofitting, and number 4, techno-legal regime, right? For the existing structures and the new structures, our focus is risk reduction. There are 2 ways of becoming rich. One is to earn more, second is to spend less. If I want to reduce risk, don't add new risk in new structures, and reduce the existing risk in the existing structures. And that is why these 2 subjects are very, very powerful for us to implement immediately in the country. First is retrofitting, and second is techno-legal regime. When I'm talking of retrofitting, I'm talking of retrofitting of the common man's house in the interior of India or in the urban India, where we will be able to prevent the collapse of the structures and thereby save lives of the people of India. Okay, with this, let's see what are the details in that. First off, you have to announce a retrofit policy. This will be done by the governments, usually after due discussion. And fortunately for us, we have a policy document already released by the NDMA. And the work has to begin with the government-owned structures, with the government's financial resources, and with technical inputs to private sector to retrofit their private structures. Also, there could be some amount of incentives provided for to the private sector to undertake retrofit. On the other side, we need to have a Structural Safety Act, which is having three major elements. One is competence of structural engineers to be ensured. Second is the process of licensing of engineers. And the third one is penal actions for those who are not complying with structural safety. Okay. The next step after the policy level discussion is to develop effective retrofit technologies. We have different structures, and for different zones, different solutions will be coming up, and we need to identify them. On the other side, we need to prepare design. We need to prepare the design and retrofit standards, which are supported by commentaries, handbooks, and solid examples. Right. We go forward. To be able to implement the retrofit, we need effective retrofit technologies, and that is what we're looking at the full-scale test to be done. And then on this side, we're looking at training competent structural and geotechnical engineers. First create the master trainers, then unleash the training program, and also build competence in peer reviewers and proof checkers who are going to be steering the work in the road ahead. When you undertake full-scale testing, that is when you will see that you will guarantee that the solutions that you're suggesting are actually effective in reducing the risk of the people of India. The training of competent structural and geotechnical engineers in both peer review and proof checking is a vital part of the development of the technical competence of the nation to undertake techno-legal regime or to establish a strong techno-legal regime. We are looking at building an approach to qualify and certify technologies, new technologies particularly, and we need to know what the approval systems are, declare that publicly, and what are the approval processes, start them, and rehearse each of them with the proposals that come to you each day passing. Launching of licensing of structural and geotechnical engineers is crucial. We need to showcase this in one state to begin with and extend it to the remaining states. We can't gobble the mountain, but we can nibble the mountain. We can pick up one state which is proactive and start work in that state. On the retrofit side, we need to build confidence in not only the people, but also policymakers that retrofit is possible and it is effective and it is in a shorter period of time and with a limited amount of resources. That is where pilot projects will have to come into picture. For that, we need to also bring risk profiling of the states, how much risk is there in each of the states, which is a greater risk, and so on, and then prioritize our assets for undertaking retrofitting. On the techno-legal regime side, we need to identify master trainers who will create the resource materials and good practice manuals. We need to launch a retrofit program, identify funding, which is there in the state disaster mitigation fund for all the states have been provided with over 1,60,000 crores of money by the 15th Finance Commission for disaster management. And so there is money available with the states. Only thing is we have to support them with technical hands who can undertake that work. And on the other side, we need to re-begin technical education in India so that graduates will come out with the knowledge on the existing or the practicing engineers will capture continuing education and do their work more confidently in the road ahead. It is said that 100 is the enemy of 80 and best is the enemy of good. So we know that we are imperfect today, but with that itself, we want to start and we want to grow forward. And this imperfect start will eventually bring us towards the direction of reducing losses of life and property as we keep erasing the two letters I and M. I is incompetence and M is the magic that we keep thinking will happen someday. Somebody will come and make the entire nation earthquake resistant. Those magics won't happen, neither incompetence will help us. Both of these we'll have to remove. Then only we are walking towards the answer that we would like to see. On the road ahead, just like to close by saying earthquake safety is a matter of human dignity and we cannot take chances. Policymakers should be guided clearly and not given multiple answers, but they must be shown the big picture so that they will be able to take the decisions or make the policies, effective policies, which are useful for the people of India. Decision makers should build confidence with pilot projects and build confidence both in themselves as well as in the people of India. People should be sensitized on the impact of initial cost of construction on safety during the entire lifetime of the structure and not go by the little 2% increase in cost will not cause an undue destruction or undue imbalance in the project economies. I'll stop here by thanking Dr. Shailesh Agarwal, Executive Director, BMTPC of the Ministry of Housing and Urban Affairs, to have kindly invited me to come and make this presentation. Ladies and gentlemen, thank you for your time and attention. Jai Hind.
Sir, so we can, sir, take some questions?
Yes, we can take questions now.
Okay. So please, I find only one question. Please write your questions in the chat box. Sir, shall I read it for you?
I'm trying
okay.
to see the chat
Sir,
box.
I'll read it for you. I'll read it for you. There is a question. Is it possible to develop a standard sample building design for each seismic zone in India to ensure safety and reduce the dependence on architects and engineers for small scale projects such as 3 to 4 story buildings? Big question.
Question is long, but no issue. Only one part of the phrase I'm a little worried. You want to get rid of architects and engineers? That's a threat to the nation. So don't get rid of them, work with them. And it is possible for us to develop type designs. They're called type designs. It's possible for us to develop type designs for each zone separately. And this is exactly what the Malaviya National Institute of Technology, Jaipur is doing, that they're developing type designs and testing them full scale and showing that this design is effective. And that is what we want to do for all zones. Possibly they have done it for one zone, but we will do for more zones in the road ahead and see that safety is guaranteed in terms of resistance and not just prescriptive construction.
So another question is, despite having IS 1893 and IS 4326 codes, implementation remains a challenge. What are the most significant bottlenecks in enforcing earthquake-resistant design in private and public construction, especially in smaller towns and informal settlements?
Yeah. First thing is knowledge is missing. Second thing is that our earthquakes are infrequent. Third is the stranglehold in which the engineers are not getting paid for the work that they're doing and they're undercoating themselves and doing work at a very small price. Fourth is there is a false sense of belief that earthquake is a force, but earthquake is actually displacement, which means that y-axis, the vertical axis, the force is, if you make a stronger structure, it doesn't necessarily mean that you'll have a safer structure, because deformability is something that we have to talk about, which again goes back to the point of education. So a clean answer to your question. First is education. Second is the competence of engineers to be able to provide those services. And third is that there is a complacence that earthquakes will not happen and that we can get away without doing design for earthquakes. We have 10,000 municipal bodies in the country we are not checking earthquake safety in any of that at the municipal level when a drawing is submitted for buildings and structures up to in some 15 meters, in some 18 meters. But there are only select towns in which there are committees set up to do a peer review of the design, but that is very insufficient. And even it doesn't qualify under a percentage discussion. It's only a numbers of buildings discussion.
Another question is on retrofitting. Given that much of India's building stock is old and vulnerable, what is the priority between retrofitting existing structures versus enforcing stricter compliance for new construction? How cost effective are current retrofitting programs?
Yeah. So one thing I learned over life is that we don't choose between left eye and right eye. And what we told today, what I showed you today, 2 items, one for existing structures and one for new structures. We need to do both of them. Don't add new risk and reduce the existing risk. So we need to do both of them. So there's no relative choice per se between retrofitting existing ones and enforcing stricter compliance of the new construction. We need to do both of them. We need to do quickly human resource development to man both of these posts so that we can go forward. How effective are the current retrofit programs? Yes. I don't know the programs, but all I can tell you is that retrofit understanding of retrofit needs to improve in the country. And we are praying that the new standard of IS 13935 will help build a better appreciation of what is retrofitting. Earlier it was prescriptive statements, but now we will go with quantitative retrofit statements.
Sir, another one is how prepared are we with regard to India's critical infrastructure systems like hospitals, dams, power plants for high magnitude earthquakes? Are current safety factors and design practices adequate for worst case scenarios?
Yeah. One thing I can tell you is that as far as dams and power plants are concerned, the nation has always taken extra care to have peer review, some extra committees and oversight and due oversight and so on. So I will not necessarily discuss dams and power plants. I'll be worried about hospitals because all these years we treated hospitals as yet another building. And so its design is no different from a normal house design. And that is where our worry would be, that hospitals need to perform better. So an urgent effort is required to fix schools and hospitals in the communities across the country. Right? So it's not about safety factors, but it's about design strategies. There are small changes that we need to do. The design process is the same. Only some small changes we need to do for making the hospitals go from normal structures to critical structure category. So we have normal, important, critical, and special structures for this very reason, that the higher structures have to perform in the aftermath of an earthquake.
Okay. Sir, there is Dr. Pradeep from IIT Jodhpur, you might be knowing him. He's asking, do engineers consider soil structure interaction in seismic regions? Since such behavior is a function of dynamic soil behavior, do they consider site-specific nature of the soil?
Yeah. So while it was always stated that this needs to be considered, there was no guidance for the engineers all these years. So soil structure interaction is at 4 levels. First is structure flexibility, second is structure inertia, third is structure flexibility and structure inertia and soil flexibility. And the fourth is structure flexibility, structure inertia, soil flexibility, soil inertia. So this new revision of IS 1893 has pushed the implementation of soil structure interaction to level 3, which is structure flexibility and structure inertia were there, but this time we added soil flexibility in quantitative terms. So this will be the first step. And the next, in some special structures like dams, we are already doing soil inertia also. But for normal structures, yes, we are at level 3 and we need to take one more step. Maybe in another 5 years, we should be there and talking about soil structure interaction. But having said that, the design spectrum already uses is different for the different soil site conditions. So there's an approximate way of addressing that, and that has been done already. in our standards.
Okay. So Bajpayee ji is asking, there is serious workmanship related issues in most of construction projects.
I am with Bajpayee ji on this matter. I think the biggest crisis, the biggest strength of India and the biggest crisis of India is the same, and that is people. The strength is that we have large number. The crisis is that we need competent ones. That means that instead of worrying about professions, that other professions are giving me more money or this is giving me less money, I am confident that those who survive in civil engineering for more than 15 years will definitely get more money in their subsequent second half of their career. One. Second, they'll be doing more exciting projects in the second half of their career than in the first. Very clearly, BTech is words, MTech is paragraphs, and MTech is sentences, PhD is paragraphs. So you don't know much even after 3 degrees. All that will happen is every 10 years, you'll add a chapter. At the end of 5 decades, you'll make a book out of that. And that is your life. So very clearly, don't ask too much money when you are just entering the industry at age 21. You know only words. If you do masters, you know only sentences. If you do PhD, you know a paragraph. So there's a long way to go. Modesty is the virtue that we're looking for in people. And if you are modest and if you are patient for 15 years, you will be there doing leading projects of the nation and saving the people of India.
Okay. Sir, will you be more questions? Can I ask?
Yeah.
What are the key lessons India has learned from past major earthquakes, such as Bhuj 2001, Latur 1993, in terms of policy, engineering practices, and community preparedness? And why do some vulnerabilities still persist despite these lessons?
Yeah. So very clearly, every earthquake has taught us something. 1988 Bihar, Nepal earthquake showed us liquefaction as reality. 1991 Uttarkashi earthquake showed us that hill area constructions are very brittle. 1993 Killari earthquake showed us that random rubble stone masonry with rounded stones, river stones, are not going to save people's lives. 1997 Jabalpur earthquake showed us that open ground story structures are a problem. 1999 Chamoli showed us that in the near fault regions, the hill area constructions are not going to survive. 2001 Bhuj earthquake showed us engineered structures are all suspect right now. 2004 tsunami showed us that we don't have an understanding of this word tsunami, and we need to protect our shoreline constructions accordingly. Right? 2011 the Sikkim earthquake showed us that the buildings on hill slopes are a problem. 2015, the Nepal earthquake showed us that the ground motion can be radically different. Long period motion can come in 3, 4 seconds, 5 seconds ground motions can come in. So long period structures will be in trouble. So no doubt, every earthquake is teaching us something nice. In terms of policy, we have learned all the lessons from the other countries even before we had all our earthquakes. Only thing is that we need to assign or apportion priority and start implementation. And the first one that I would do is actually education. Because there is a lot of misinformation, ill information, or disinformation about what is earthquake safety. And so my first pitch will be, if I were to start for long-term initiatives, it will be education. If I were to start for short-term education, it will be these 2 points that I mentioned today, retrofit and techno-legal regime. We need to fix these two. Okay. So there is another question. You're muted, Shailesh.
Sorry. So there is a question from Andhra Pradesh State Disaster Management Agency. Andhra Pradesh falls under seismic zone 2 as per hazard zoning map, considered a low risk area for earthquakes. Because of this classification, many policies and construction practices in the state tend to overlook earthquake resilient infrastructure and mitigation measures. However, events like 2004 tsunami triggered by an undersea earthquake highlight the vulnerability of coastal regions to secondary hazards such as flooding. How can we effectively educate civil engineers, administrators, and general public about the importance of seismic safety and tsunami preparedness even in low risk zones like ours?
Yeah.
Good
So,
question, sir.
thank you for the question. Yes. The two things about Andhra Pradesh. First is that only part of it is in zone 2. A significant part is in zone 3. In fact, we had to revise the zone map this time because of the shaking in the Nellore region, right? So our worry is that the state has both zone 2 and zone 3. But the biggest crisis is nation's two largest rivers are coming out of the state on the coast, which is Krishna and Godavari rivers, which means there's a large land parcel which is sitting on soft soil. And I'm seeing a large number of tall buildings being built on soft soil. Soft soil means long period, soft construction. Tall buildings means long period. Both are going to match. Should there be even a small shaking, even in low shaking, these long period structures will start walking. And that is my worry, that we are taking this too lightly. A comprehensive understanding of the state's vulnerabilities has to be brought onto paper, and we need to implement urgently. Low shaking and the flexibility of soil will mean at the surface large amount of shaking. And that is what we are recognizing now, and we are praying that the government of Andhra Pradesh will take effective action immediately to build safety. Now, for this, the issue is if you sell in a state with low and moderate earthquake shaking, earthquake safety, they will not take it. But what I'm saying is earthquake is one of the 18 loads you have to design for. Let us build structural safety practices which don't exist in the rest of the country also. That there is no peer review anywhere. There is no verification of safety at the municipal level anywhere. If we can start that work in the state of Andhra Pradesh, it will be the first one and the leader to showcase the country that it is possible in India to give priority to life, and we can fix the matter of structural safety, which will include the earthquake safety pass. Remember that the crisis of Andhra Pradesh is the annual event, which is cyclones, not annual. 5 times a year, 4 times a year, sometimes more number of times a year. Cyclones are going to hit us. What are cyclones? High winds and heavy water. Both of them are a crisis for us. And so Andhra Pradesh is placed as an ideal candidate for us to build structural safety at the earliest opportunity. And that will be my request.
Sir, there is a question from Manipur, Mr. Kosi. Does the Bachelor of Architecture syllabus in India adequately emphasize earthquake-resistant design and construction of buildings, or is this aspect largely overlooked in architectural education?
Yeah. What I am given to understand is that in architecture curriculum, 80% is mandatory, 20 is flexible. Whenever there's an earthquake, in this 20 earthquake shows up for a couple of years and then goes away until another priority comes in. And that is not a good practice. We want to build earthquake safety as an innate part of the mandatory curriculum. Only then all graduates, architecture graduates, will be sensitive to the form. The irregular form is not good. This point will come in only if they're sensitive to that. And that is why I would say that there is a need for coordination to review the both the engineering as well as the architecture education in the country.
Dr. Rao from IIT Hyderabad, he's asking that urbanization is happening rapidly in seismically sensitive regions like Delhi, Mumbai, and Himalayan foothills. How should urban planning policies be strengthened to integrate earthquake resilience, considering land use constraints and high population density?
Yeah. So it is not about these few cities. The whole of India is going through this rural to urban migration. We are 30% urban, 70% rural today. And in about 25 years, we're going to swap, become 70% urban, 30% rural, which means that we will be 2.3 times what we are in each of the urban centers, which means that we are going to load up, even though some of the land is increasing, we are going to load up all the requirements of utilities, water, power, sewage, transport, all of that in a very local food in a localized area, which is not good quality of life. My pitch for the future would be that we do proper land use mapping and land use planning and move people to neighboring areas and have rapid transit system as a method of coming into the city only when you need to come. Otherwise, the quality of life has to be raised. You can have all the offices, new licenses of all the big corporate offices should be given in interior areas connected by a rapid transit system to the nearest airport. If that is what they want, only an international airport and a big hospital, we can construct the hospital, even in interior areas. But big airports, possibly, we will have to bring a rapid transit to connect that to the interior areas, which are to be developed in a planned way. So I would not subscribe to loading up and going tall in these limited areas, but I would rather go fewer stories and spread out rather than stay at all in one place. And there are other perils of being all concentrated in one location, which I don't want to necessarily discuss here.
Sir, there is question from my side because a whole lot of engineers from state governments have joined. So sir, my simple question is, we are at the crossroads where, at ministry, we are trying to push, new construction systems. We are really working very hard to transform the construction sector by bringing these precast and other, next gen technologies, use of IoT and all these things. So what is your take on this? Because most of the time we are being questioned about its earthquake resilience and other aspects, So what would be your suggestion? Because at one side we want Viksit Bharat and introduce these new technologies to take India forward. And on the other side, we are thinking in terms of all these things. And there is another, thing is that these are already time tested and proven elsewhere in the world. So what do you suggest to us or other implementing agencies across who have joined today? What kind of cautions we should take or measures we should take before implementing these cutting edge new age technologies or emerging, whatever you may call it?
Yeah. So penny wise, pound foolish. We are saving a few rupees and not doing testing in the country. I have been after all these companies, whoever want to do new technologies, we welcome all new technologies. There will be a process for admitting new technologies. Everyone is aware of that. All that we require, there are 3 steps: analytical work, experimental work, and then standardization, and then it becomes a new technology. So analytical work is relatively simpler. They can do it in their own offices. But experimental work, full scale, will require you to do testing. Now, there are 3 laboratories in the country already, which we have built over the last 2 decades, and where we can do full scale testing. Nobody is being stopped from getting their products tested there. So first thing is, they must put their hands in their own pockets and spend some money. And this is a business strategy, and show that their structure is safe.
Okay.
That is the first item, to build confidence to the people of India. Second one is that when you say that this is trial tested elsewhere in the world, our standards are different. These structures built on our land have to comply with our standards. For example, the pre-engineered buildings in the country, there is no standard for that. It is being built as per a society document called the Metal Buildings Manufacturers Association of America. And how can we really take an association's document and say nation is safe, because that association in America, which they themselves are not building in large numbers, we will build in large numbers? I think it is inappropriate to extend this logic that people in the other countries are bathing in milk and sleeping on gold. I don't think that is correct. We need to do testing because our loading standards are different. Our capacity standards are different. They have to comply with the law of the land, and then only they'll be admitted formally. They can say anything, but so long as they don't comply with the law of the land, this pain will continue to happen for the new technology providers. My invitation to new technology providers, don't hesitate. Please spend a little money at the beginning. In the whole life cycle, this money will come back to you. And do show confidence to the people of India that the structure will survive. That's all that I'm seeking from them.
Thank you, sir. Thank you, sir. There is a question from Mr. Jaswal, who is smiling, and he's asking, why is still earthquake engineering is not taught in undergraduate levels as a compulsory course?
Yeah. So when we were doing 5-year BTech program, we did 65 courses out of 75 to be in civil engineering, and the remaining were maths, physics, chemistry, workshop, and drawing. Right?
Yes.
Now there are 42 courses. Out of that 42 courses, there are only 7 courses are civil engineering. Okay, 17%. From around 85%, we've come down to 17%. So obviously there is no real estate available to put earthquake engineering there when the fundamental subjects of structural analysis, structural design, basic mechanics are all not necessarily finding a space, or they're fighting hard on the ICU to get into that curriculum, right? So there are bigger issues that come out. What is possibly happening is undergraduate and or happened already, undergraduate education in India, even in engineering, has become a generic degree now, not a subject specialization degree. Right. So if you want to learn subject, you have to get into the first master's degree and learn the first set of courses. And then if you still want to learn the subject more, you have to do second degree. Remember that in 5 years, we got 1 degree, and today we are giving 5 years, 2 degrees, which means the quality of education has fallen down. Standards of education have also fallen down over the years. Let us accept it, but you say that we need to do lots more work to become competent to be able to serve the needs of the nation.
Very nice, sir. Nice, sir. Sir, another question is from MP Singh from Rookie, I think. He's asking, we have in Uttarakhand, we have an app for early warning.
Yeah.
Do other states should also look to implement such type of apps for earthquake early warning system?
Yeah. So let me clarify the story of earthquake early warning and earthquake alert system. If the earthquake is right under your foot, then you only get an alert. If your earthquake is 200 kilometers away, you will get a warning of 40 seconds. Now, even if I give 40 seconds to any big city that you're going to get a magnitude big earthquake 200 kilometers away in the next 40 seconds, will the 2 crore population vacate that place? Will go away somewhere? They can't even come down their building and assemble in a place in the ground floor because there's not much land left anyway in the urban areas. So my observation will be that alerts and warnings should be used for automated shutdown of the systems that are there across, right? Then alerts and warnings should be used by people for, if the building is safe, you can go under your table and do what is called drop, cover, and hold. If the building is not safe, that is where my worry is. Even drop, cover, and hold will not survive for us. But we must continue to practice drop, cover, and hold if we have to reduce panic in the people. Otherwise, they're coming down the staircase, and Gujarat earthquake showed that the staircases themselves are not necessarily safe. And so there is a deeper, issue here on alerts and warnings. We have to use it judiciously. What is important is that we are able to use the instrumentation and help our disaster response force to go to the correct places and provide emergency services at the affected areas, and not go here and there, but go to the needed areas. That is what we should be able to do with this early warning and alert system outcomes, which are basically heat maps showing you where the shaking has been large and so on.
So there is another question from Rao from IIIT that seismic microzonation studies are available for few major cities in India. How practical is it to extend microzonation nationwide, and how can planners and engineers incorporate site-specific ground response into urban development?
Yeah. So one of the important on the central outcomes of earthquake microzonation is actually land use planning. If a place is subject is potentially an area where it is likely to liquefy, or a place is likely to have major landslides because triggered by the earthquake, then such places should not be the pockets for having habitation developed or having emergency services like hospitals, water, power, sewage treatment plant, and food services, and so on. So there is a huge work to be done by using microzonation for land use plan. But the interesting part is existing structures, existing towns, what do we do? Whenever we say you have to vacate this place, it is not safe because there is a landslide likely to happen, there's a huge resistance. So that part will require the involvement of policy makers and decision makers to negotiate slowly over time But all new developments, at least, should be directed to land parcels which are necessarily having low risk of earthquake effects.
Okay. Sir, I think somebody is asking, but let me just answer that we will be providing the video recording of entire deliberations and lecture of Professor Murty on our YouTube channel, and our link will be given to all of you. Sir, can we use can we give your presentation in PDF format to all the participants? Or?
When you give the video, why do you need presentation?
Okay, okay.
It's all there in that. They can stop and see every bit of it. And
okay. So anyway, okay, so we will just provide you, so rest assured, we will provide you the video recording of the entire session.
We are
link.
developing a new material which we will release shortly, which will have all the slides that we are showing today. The reason why we cannot give you officially any slides is that large number of pictures are taken from the internet. And some of you will start selling these, and that is where you will get caught.
Correct.
And so don't sell any of these. That is what is our suggestion, that in earthquake engineering, we want people to share to reduce loss of life. The day you make it commercial, then it becomes very difficult for you to fend yourself.
Sir, since a lot of technology providers have also joined today's session, so if you or Professor Bharti can explain that if they want to get their technology tested, how should they go about it? Whom to approach? What should be the procedure, Professor Bharti? If you could explain, if you find it comfortable, can you just tell the technology providers that what is the way out, how much time it takes, and how should they approach you?
See, Namaskar. Thank you, Shailesh ji. See, if I come down straight to the actual testing part, for a 3-story, let's take example of a 3-story structure. The erection of the 3-story structure shall be the responsibility of the technology provider or the person who is bringing the technology here. So once the erection is done, which will be the responsibility of the technology provider or technology owner or technology developer, the testing would typically take about 15 days. 15 days meaning thereby instrumentation and then fixing of all those things, and then subsequently dismantling and removal again will be so for our part it will be 15 days for testing, which includes erection of systems for mounting sensors, moving the actuator and connecting to the building or whatever is the system. So about 2 weeks time. Besides that, we'll have to account for other activities which will also take time. Say, let us say 2 weeks is up for the testing. About 2 weeks, please understand that all these timelines I am giving for considering a 3-story building, about 10 meters or 10.5 meters tall. So 2 weeks for testing, 2 weeks for dismantling, which will be actually the responsibility of the technology provider. The person who owns that model. So for us, 2 weeks, for them to remove the specimen, clear the floor, 2 weeks. So that is 4 weeks. Besides that, depending upon what system they are using, they might take 3 to 4 weeks for sample the model erection. So 4 weeks. So that is when actually you start doing the laboratory activities. 4 weeks, 2 weeks, 2 weeks, about 8 weeks. Besides, but before you actually commence the strong floor activity, there may be, depending upon how committed they are, how much time they are devoting, they may take any time. For the erection of, components, bringing them here, shipping here, all those things. So from our side, from floor, the floor occupancy will be 4 weeks of erection, 1 week of testing, and 1 week of removal, 6 weeks.
And will you be giving them a certificate kind of thing that
we will be giving them the complete force deformation behavior of the structure, and then before actually we start erecting the model, we'll have to develop a detailed discussion. What are the monitoring stations? What are the locations where will you do the monitoring and all those things? and we will give them complete report, documentation, video recording, everything. And we'll give them the complete description of the behavior, damage patterns, and all the details. I mean, all the details which are necessary for technology to improve upon or technology to validate upon.
To Professor Bharti.
And one more thing. So far, we have done 7 models of 3-story building test.
Okay. Okay.
So we have kind of accustomed that how to optimize the floor occupancy and test.
So we'll keep a session. Rupen, would you like to add something in light of questions? So many questions were asked. Professor Murty answered. Would you like both of you, since I find you here, anything you want to add?
Okay, Jaswant, go ahead. If
Yeah.
there's anything you want to first add.
Or seniority.
Just it's okay.
He's my
Just
senior, by the way.
Yes.
Senior, but he looks young. He looks younger. Yeah. Okay.
So thank you, Dr. Agarwal, for the opportunity. I'm glad that Dr. Murty could discuss this in this session, basically because the overarching topic is slightly different from earthquake safety. But this is an important step into understanding what our steps are towards developing new codes. And like Professor Murty spoke at the beginning, it's a comprehensive improvement to the code, and the next revisions would be incremental. So it's an important step. It's going to be a painful change in the code because it's a major change in the code. And we are very glad that BIS is working towards this effort. But in terms of understanding what is going wrong and what is the improvement, it will take a little more time for us to get there. It won't be a overnight understanding of the code, even by the most people who understand the language of earthquake engineering. Here, like in the session, Professor Murty also spoke about, and even Mr. Arvind Jaiswal pointed it out. Why is this subject not taught in curriculum? So that's the first step. That we should bring this down to the lower level, at the basic level of engineering, at the bachelor's level, and teaching in the colleges should happen more importantly before we are able to say that this is the new code and go and practice it. The understanding of the code will come through engineering colleges. So that is what I would like to say. Thank you.
Professor Rupen? Yeah.
Just to continue on that. So the things are that Indian standards are the first step. They are being revised, and we will soon have the new standards. But then I think dissemination of of that standard to each and every stakeholder, students, teachers, professionals alike, and also industry partners, I think is going to be a major activity in days and weeks and months. So that's the first thing. The second thing, I think we also have to start looking at the standards as something that is being done for good of the society, rather than, and that acceptance is important to begin with. If we, many a times we have seen that a lot of questions, a lot of apprehensions are put forward right at the beginning. Rather, my request would be that we first look at the changes in a positive way and see, and always keep in mind that these are for the betterment of having a better built environment in the country in years ahead. So that's the first thing. The second, the other point is, of course, there are, as you also mentioned and highlighted, that there is need for bringing in new technologies. But then those new technologies should also, give us confidence, and that confidence will be able to gain if we do proper testing. So all these activities have to begin, and the key thing in all of these, I believe, is participation from each and everyone, starting from even a first year or second year BTech student. Although it may not be taught in your college, but if you have interest and if you are willing to be part of this whole community whose responsibility is to provide a safer built environment to the country, then it's time that you also start looking at these and make your little beginning by attending these kind of things and then trying to learn on your own. I'm sure you will find enough people to who will be happy to share the knowledge and expertise that they have. So each one of has to make our own bit, put in our effort, and then only we will see the fruit of all this effort.
Thank you, Rupen. Sir, there is one question from SDMA. Would you like to take it up or we?
Yeah. Let's
Yeah.
read that.
Sir, this is again from Andhra Pradesh State Disaster Management Agency. A centralized digital portal where structural designs submitted in AutoCAD or CAD or other standard formats can be uploaded for automated evaluation. The system would assess each design against the latest.
Mohammed Wasim sir, please close your.
Please mute your mics, please. So what he's saying that can we create a digital portal where we can put the structural design and then system would assess each design against the latest IS standards, assign a compliance score and issue a certification for structural safety.
Yeah, maybe the language that was written is seeming like there's no human intervention, but I must confess that the electronic building permit system is in the active cards of consideration at the highest level. And the Bureau of Indian Standards has also given consent to this, that they will oversee the work of the clauses being implemented. Remember that this electronic building permit system is not just for earthquake safety, but for all the 18 loads. So it is necessary. The only thing that will happen is uploading AutoCAD files will not solve the problem. What will solve the problem is that in the design process, there are critical steps and we will ask information about those items and you will have to put in those numbers along with the design calculation supporting that. Only then the peer reviewer who is going to examine this at the municipal level will be able to sort of say that it has been complied with or not. So what we are checking is compliance with the standard, the provisions of the standards, the relevant standards is what we are checking. And that is going to come up soon. Now, if APSDMA would like to take this up urgently, then it will get traction because right now we are trying to do for the nation, which can become slow. But if AP is interested, we can readily get started with this and implement it for the state of Andhra Pradesh. Later, give us permission to customize the same software for other states so that AP will become the mother and all the children will also get food from AP as far as safety is concerned.
So that is possible, you mean to say?
It is possible.
Okay.
It is possible, but a slightly modified version with a lot more human intervention than it seems from the text that we are reading.
Okay. So, sir, I think there are no more questions. So before we sign off, I request everyone to switch on their cameras so that we can take a virtual photograph of this session. Please switch on your cameras. I will take a photograph.
In fact, my appeal to the nation will be that every time you attend any meeting, please switch on your video. Anyway, it looks so wonderful now to see faces. Otherwise, if I meet you at the airport, I cannot offer you coffee. Right?
Yes, sir. Thank you.
If you don't switch off your video, then you lose an opportunity for a free coffee at the airport or railway station. Yeah.
Okay. Thank you, sir. I mean, how should I propose vote of thanks? We love to hear you on and on. You know, should be never-ending kind of thing. So thank you very much for joining this lively session, and I sincerely hope that in future also we will take you on board and educate our participants about the new things about earthquakes and all. And definitely, sir, before I retire, I would like you to speak, take a session on Indian standards, what new things you are doing, because all of most of the participants, they are already asking me that let's have a session on Indian standards. What new has come and in what way it will help to create resilient country. So with this, I sincerely thank Professor Murty. I also thank Professor Bharti, Professor Rupen, and Professor Jaswant, and all the participants. And rest assured, we will give you the video recording. I see Karam Chandani ji. Would you like to ask something? Sir, Mr. Karam Chandani is running a software and teaching, free of cost software is running. Would you like to ask something?
Namaskar, Karam Chandani sir. After a long time.
Namaste. Thank you for giving me the opportunity to talk. I am really humble and I will come personally again to meet you all. And that is a very good platform that you are giving the opportunity to all and make the safe structure. Thank you.
So thank you once again to all of you, and please accept my Diwali festive greetings to you and convey my regards to your all family members. May the next year be as good as this year for all of you. Thank you, sir. Thank you,
Thank you,
Murty, sir.
Shailesh. Thank you, Shailesh. The Bureau of Indian Standards is quickly releasing the 6 new standards. So as soon as I get news that they have been released through the Gazette, I'll come back to you saying that we are ready for the webinar, and we should do a lot of that.
Thank you, sir.
Thank you so much for the opportunity. And I guess it's like medicines. We have to take in small amounts at regular periods of time.
Okay, sir.
Only then we will get well. So let's come back again
Okay,
and
sir.
hear another story. This is one story today. Next time we'll bring another story to you.
Okay.
Or
18th,
it's
sir,
more like a medical checkup to add new things to your working.
Okay. Thank you, sir. Thank you.
18th November
Good
we are
sir.
meeting. Sir, Murty sir, 18th November, I have already booked everything. 18th November, we are meeting for new technology roadmap. Thank you.
Thank you
Just
so much. Thank you again, and happy Diwali to each one of you.
Happy Diwali to everyone. Yeah. Thank you, sir.
Thank you.
Thank you.
Bye, sir.